So this video is on the objective calculate a point estimate given a confidence interval. And it is the first question from your Newton Alta homework that I'm seeing with this, that I'm doing a video on. And let's take a look. So again, I'm going to say this every video. If you are unfamiliar with the topic, again, hopefully you've read from your OpenStax book, the Chapter 8 introduction. But also if you're seeing it here for the first time and want to see more about it, how to do problems or what the material's on, how to look at the topic, click on More Instruction button and take a look at what they have to offer. Alright, so this question here, a random sample of accountants were asked whether they double-check their calculations on a tax form. The resulting confidence interval for the proportion of accountants who double-check their work is 0.89 as the lower bound, 0.97 as the upper bound. So what was the sample proportion p hat for this sample of accountants that were asked whether they double-checked their work? What proportion of that sample, if this was the confidence interval obtained from that, what was the p hat? What proportion of the sample said they double-checked their work? So to answer this question, we have to remember how a confidence interval estimate is formed. Now remember, a confidence interval is a guess, a range of guesses as to what the population proportion is. Right? So this confidence interval is saying that, hey, we're reasonably confident, whatever the confidence level is, we're reasonably confident that the population of accountants, right, all accountants, the percentage of them that double check their work is between 89% and 97%. That's what this means. But we're asked to find, well, okay, for this one sample, what was the proportion? What was the p hat? So again, we have to remember how confidence intervals are formed, and I'll refresh your memory here. So remember, confidence intervals are formed this way. Now, this is about a population proportion, so p. So we're reasonably confident that p is, between these values of 0.89 and 0.97. Now remember, the upper bound of a confidence interval is formed by taking our point estimate, which is a single value from the sample. In this case, that would be the p hat, right, the sample proportion, and then adding to it the margin of error, right, which is usually abbreviated ME or MOE or EBM for error bound to the margin. And then the lower bound for a confidence interval is formed by taking the point estimate, which again in this particular case is our sample proportion, the p hat, and then subtracting the margin of error. Right. So we're given this interval that 0.89 and 0.97 are the lower bound and upper bound. Now they gave it to us as an interval with parentheses. Right? They gave it to us this way, but it still means the same thing. Right? They said they're reasonably confident that the percentage of all accountants that double check their work, the population, is between 89 and 97%. Well, again, looking at how a confidence interval is formed, p hat plus the margin of error, p hat minus the margin of error, the point estimate, then the p hat, the point estimate is exactly in the middle, of a confidence interval. So how do you find the middle of two numbers? Well, you take their average. Right? You take their average. So noting this, p hat, right, the proportion of the sample that we took, the sample of accountants, the proportion of them that double check their work will be 0.89 plus 0.97 divided by 2. Right, you just take the average of the lower bound and upper bound. Alright, so 0.89 plus 0.97 would be 1.86. Pretty sure. 170 plus 16. Yeah. Then cut that in half. Right. So the proportion of the sample of accountants that we took that double checked their work is 93. That's half of 1.86. That's the exactly halfway in between these two values. And then we could also use this to find the margin of error. Now we're not asked for the margin of error here, but if I know now that 0.93 is in the middle, what's the margin of error is just the distance to the lower bound and upper bound, right? It's p hat plus the margin of error, p hat minus the margin of error. So 0.93, plus 0.04 would be 0.97, and 0.93 minus 0.04 would be 0.89. So you could also get the margin of error is 0.04, right? So another way we could talk about this confidence interval guess is we'd say, hey, the proportion of all accountants, right, the population that double check their work is 93%, give or take 4%. 0.93 plus or minus 0.04. It's another way we could say this same confidence interval. All right, but we were asked for just the p hat though, right? Just the middle of the interval. So p hat, the average of the lower bound and upper bound, 0.93. And it's really that simple. And again, read through the answer explanations and all that. They're doing exactly the same calculation I did. Right, and yeah, so this is just the first question on this. I might do one more. Right? It's pretty easy, this objective. And yeah, and thank you very much for watching.